Here we have a vintage Pioneer quadraphonic receiver. This was actually, I repaired this probably a year ago. It's interesting, I don't remember that button being missing. I don't think I made a video on this. I tend not to make videos on stuff like this because you have audiophile people that tend to be extremely passionate over this type of stuff, and although these are cool, I wouldn't consider them anything to be passionate over. The problem before was a noisy small package like a TO92 transistor package, little plastic, in the speaker protect relay circuit, so it would just, even though the voltage, you know, there wasn't a high DC voltage coming out of the amp boards, it would just randomly kind of cut the relay off, and it took me a long time to find it. It was a noisy transistor in the relay driver protect circuit. That's weird. I don't remember that missing. If all prepared, they just bring out the DVD and roll it out. So let's see what happens here. Auto FM. AM. Why am I not seeing any signal strength on FM? Oh, I just heard it click. Hear it click in there? Let's see, bass. Where's the volume? Let's turn the volume down. Sometimes these speaker protect circuits are more trouble than they're worth. There's no problem with the amp, it's a stupid speaker protect circuit. What that's supposed to do is if one of the audio output transistors shorts and puts a high DC voltage on the speaker, that circuit senses it and cuts it off so it doesn't burn the speaker up. Okay, this is the protect board here, right here. And that metal one there is the one that I put in here, and it was one of these small ones. You know what? Having Diane Sawyer going on in the TV in the other room, Xanax infused cigarette smoking. Besides the relay, the protect relay clicking in and out, I'm clipped right onto the output of the amp here. I'm getting a lot of noise on all channels, and I hooked an FM antenna up, and I'm getting that's wide open. That was a volume wide open. I think this tape monitor switch here is depressed, but I can't. I can't move it. It's like it's jammed. And these tape monitor switches are a real pain. A big problem with those getting depressed and people not knowing what's wrong with the thing. So I need to try and work with that switch.
We'll complete the application in about 4.
Well, this switch is definitely one of the problems.
Yeah, the money's a little expensive, but it can provide welcome relief from your cash headache, and it's a lot cheaper than a paid. Because there's net fee or repayment, and then change your spending habits to keep the headache from coming back. So for quick...
The detent has completely gone out of that switch. Now the noise... The noise and the cutoff are something else. And I know 3 or 4 people have been working on noise problems. I know Radio TV PhonoNet had one that was a resistor. I know Matt's got one and a phono amp problem he can't figure out yet. And I think Battery Maker had another something, noisy germanium transistors, which germanium output transistors are just way too unstable. I'm to the point now where I just change those and rebias. It's actually cheaper because those TO3 packaged germanium output transistors are like 25 bucks a piece. So I guess what we need to do is take a look at the voltages on all these channels. I mean, this is one of those, how do you even begin to troubleshoot this? It's doing it on all 4 channels evenly, and it's doing it on AM, FM, phono, with the tape monitor pushed in. Base function mode. I mean, it doesn't matter. It doesn't matter what anything's on. It's just got this noise. I mean, is the board introducing noise into the power supply? Is the power supply introducing noise into the whole thing? These noise issues are really hard to troubleshoot, and we're seeing more and more and more of this stuff as this early solid state stuff ages. I mean, that's horrible. Okay, this is looking at the power supply right off the filter capacitor. Okay, it's off the charts big on these 2 filter capacitors, and it's not so big on these 2. And there's 2 different voltages. There's for the pre-drivers, and then for pre-drivers and drivers, and then the output. And it appears that this is, good question, I don't know which one it is, but of course it stops right as soon as I put the camera on the thing. There we go. So we'll go over to this. Very minimal, so maybe it's the diodes, the rectifier bridge. See, there's a positive and a negative voltage that come in here, and then there's also back here there's a positive and negative voltage that feed everything. These schematics are, I mean, you really just have to like sit down with this and study it. These things are just very, very crude. And then of course, you know, whoever scanned it in. So yeah, here's the power supply. And these are the 2 supplies. And I mean, there's not much to it. All there is a bridge rectifier and some capacitors, but I guess it's possible that it could be the load too. It could be one of the output transistors causing kind of a funky staticky load on there. But man, for those big filter capacitors, you'd think they would knock that noise off. Those are 10,000 microfarads. 10,000. So maybe one of these diodes is breaking down and failing. I have disconnected the positive and negative voltage off of both amp blocks from those two capacitors right there. And the noise is largely gone, but not totally. I believe this is just a little 60 hertz hum here. I don't know if I can get it to lock on this. So there's some noise here. I think my next step is going to be to put a light load on this, like maybe a light bulb, and see if the noise is more apparent under load, because the capacitors will of course absorb more noise with no load because they're just floating. Okay, I put a light bulb in there and it really didn't change the noise at all on the scope. And then I noticed that it's only doing it when I hook the speaker up. And look at the speaker. There's a bit of DC there. Now, I hooked this amp up and it's doing it. Maybe I'll hook this amp up. Okay, I'm changing my course now. I should have done this first. I'm kind of going about this the wrong way. This is looking at the input to the amp. Of course, it's not going to do it now. So the amp is simply responding to what's going into it. And the reason why I didn't look at this beforehand was because why would all four channels be doing this identically? But this is the thing, this is how all this crap interacts, and probably I wouldn't be surprised if all four transistors went bad at once. So what we need to do, and this low frequency DC crap, it could very easily be what's causing this protection circuit to keep the thing locked out. So the noise on the power supply was just simply the response, what you were seeing from the speaker loading the power supply down. That's why it became much more apparent when the speaker was connected, because it's pulling that current through the power supply. Okay, so all of that comes out of here. This control amp assembly. These right here, this is the output. This is the output. So what's common between all four of these is the power supply, of course. I love how it doesn't even give values on this schematic. Oh yes, it does. It gives values on this one. Okay, so it gives values on one of the four. So yeah, this is the B plus line right here. So the B plus goes up to a 330, 8.2K. I'm going to guess that there's a 47 at 50 tied from each one of these to ground. I guess the next step is to see if the noise is coming in here on the back side of this. But it seems like this is the high and low pass switch. So this is probably bass and treble here. There's one there and there's one there. Wonder where the volume control is. Let me get back here. Let me find this board first. Okay, so now I'm on the input of that board. And you can see the noise there, very, very minuscule. This is the board that has the bass and treble and noise filter. There it goes. But the interesting thing is, right, so what's interesting is we see that noise there. Even if I just take and short this to ground, I'm still getting the noise. So I'm thinking the noise is being created on this board somewhere, and then it's just feeding through the whole entire. In fact, let me try this. Let me disconnect the speaker. That way it stops screwing with the power supply, and I still see the noise there. Boy, this is a tough one. This is a real tough one. Okay, I might be getting closer here. This, what you're looking at now, is the power going into this board. And I'm pretty high up. That's on 1 volt per division, so that's a huge. That's huge. Okay, that voltage is pretty much the B plus for all of the kind of the low level signal processing audio circuitry, and it's coming off of that transistor right there, that TO220. And what's interesting, I don't know if you could see this, but it looks like that lead has been cut right there and resoldered. I'm suspect anytime I see something like that. And that, I scope the collector, which is the tab of that thing, and I see all this noise on there. So this is a low voltage power supply here. This is that supply line right here, and look, this is that transistor, and looking at the noise on the emitter is much greater than the collector or the base. So this is the one that's got the lead cut. I'm thinking about changing that. That's the emitter. Now it could be one of these small transistors back here. Like I'm looking at that one right there. See how that one's a little bit... Looking at that one right there. Spray that thing with a little freeze spray. Interesting, it kind of quiets down when I freeze that one. I don't know. I'm going to have to just start changing parts here. I guess I could disconnect those and see if maybe the static is coming from a load, one of these loads. Man, these noise problems are tough. Well, there's a resistor here. There's a 3.3 ohm. And one side of it is connected to the emitter and the other side is the supply coming out. And it's definitely bigger on the transistor side. The noise is bigger on the transistor side than the other side. So I'm going to start changing transistors here, and I might just defy logic and change the little driver first, the one that looks odd. Because someone has definitely been in here.
100 Brussels sprouts, 40 ounce of malt liquor. It's time to eat healthy today, folks. Woo! I love Brussels sprouts, but I ain't never seen 100 at one time there, boy. Whew! Let's get it.
This is day number 2. I've had overnight to sleep on this, and I've thought of some more diagnostic procedures, kind of unconventional, because I want to prove without a doubt that the problem is on the power supply and not one of these other boards kind of randomly shorting out and causing the spiking or voltage dips. So what I've done is I've lifted that resistor there, which essentially disconnects the output of this power supply from everything else. And I've connected this 28 volt bulb to act as a load, a small load to the power supply. So let's turn this on and see what that voltage regulation looks like. Well, that looks about like what it sounds like and what it looks like on the scope. Of course, the automatic iris in the camera will adjust for a lot of it. Okay, well that proves that the issue is on the power supply. So tomorrow I'm gonna start changing some transistors and see if we could get this to stabilize. Oh, and I forgot to call the owner today. I got busy and I forgot. I wanted to call the owner and tell him that this was definitely a problem, and it's very possible that there's a bad transistor on the protect board, and ask him about the switch on the front. This is a 2SC 1318, which is the driver for the regulator here, and I just pulled it out and put a 2N2222 on the bottom. So here we go. We're going to see what happens. Maybe explode, who knows. Obviously that was not the noisy part. I thought I would just kind of take a wild, educated guess and change that. That's obviously not it. Okay, on to the TO220 package output. Okay, I changed the regulator transistor, the output, and that wasn't it either. Oh, well, now it's behaving, but when I turned it on, was flickering like a candle. Oh, there it goes. Let me do this and turn this off. Let me. Wonder how much is on this collector. I don't want to burn my. Oh, that's screaming. No flickering there at all. Rock solid. So it's not the voltage going into the transistor. Okay, where to go from here? Huh. This is a fairly simple circuit. We have a output which I changed, a driver which I changed. I haven't changed this. I believe that's a Zener diode. This is an electrolytic capacitor. I guess I could take a look at this point right here and see if this voltage is sitting still or what this looks like. Okay, so this voltage right here is rock solid at 13.2. Rock solid. Maybe I should take a look at this voltage right here. I mean, there's not much else it could be. It could be not that. It could be one of these resistors or this transistor. Let me take a look at this between a 30 and 36K. I checked this voltage. It was rock solid. Then I measured this right here and it was all over the place. So I kind of bent the transistor, pushed it off to the side a little bit, and it stopped flickering. Now it's rock solid. And all I did was bend that transistor. I'm pushing on it and bending it right now. Nothing. So I'm going to change that. I'm going to replace this transistor. I'm just going to put the 2N2222 in there, and then I'm going to put everything back. And that makes me wonder, because that's a 2SC945, and I wonder what these were right here, because these were the ones that were doing that before. The 2SC869. That's a different one. What's this one? Just wondering if it was another 2SC945, but yeah, I bent that transistor. I kind of pushed it over a little bit, and now it's rock solid, so I'm going to change it. Okay, I changed the 2SC945, and we look real good. We're right on 30 volts, which is where it's supposed to be. The light looks rock solid. I haven't seen one flicker. I've still got the resistor here disconnected, so that the amp is disconnected. The stereo unit's disconnected. So what I'm going to do is I'm going to just let this run for 10 or 15 minutes and see what that light bulb does. Okay, continuing on with the 4-hour video on the Pioneer QX 545, or what was this thing? 949. Power supply has been reinstalled, and all the amps have been hooked back up, and I have the speaker connected directly to one of the amps here. It's powered up. Oh wow, the protect relay kicked in. Let's turn it off. Protect relay is right here, so let's see, I'm going to turn it on, and let's see if that guy clicks in. Power now. Clicked in. Turn it off. Power up. Clicking in, looks good. Okay, now I'm connected to the output of the relay. Here we go.
Always been inspired by Jim's poetic lyrics.
I mean, when Jim first laid out these lyrics, some more.
Watch this when I tune it.
Never getting no better than this. Giving you that you miss a better preference. Watch me turn them to skeletons.
Why is this thing feel so loose?
Think of that smoky smell on your clothes, in your house or car.
I don't have an antenna on it, just a little 2-inch piece of wire. We're driving Cadillacs in our dreams. I think Cadillac is the last car I would ever drive in my dreams, but whatever you aspire to be or do in life, I guess. Whatever floats your wagon is good with me. So here it is. Here's the culprit. It's right there. So that's it. And last time it was in for service, it was this one right here. So it's, forget a recap, it needs a retransistor. So thanks for spending an hour and a half watching this stupid video.